Good morning, everyone. How are you doing? How is NDC so far? Good? Awesome. I want to talk today about how we can shift from application security to developer security. And what do I mean by that? If we talk about security, and if security is important, everybody knows it's important, right? So none of my customers says, no, we don't care about security. Everybody cares about security, right? And here are just some numbers. The loss caused by cyber attacks exploded from 2020 to 21 from 4.1 billion to 6.9 billion. I don't have the newest numbers from last year. The report is not out, but it's probably the same, right? So the losses go up. Security is important. Everybody says security is important. But if you talk to developers, then you find that normally security is a burden. It slows us down, and if you look at the security posture they have, they're not very mature. Why is that? And I have an analogy for you, and I want to compare security with two very important inventions in the medicine field in the 19th century. And they're both in this picture. And one is anesthesia. Anesthesia was invented using ether in the 19th century, and it was widely adopted in a very short time. The other one was antiseptics, here on the right, from Joseph Lister, and it was a completely different story, right? So anesthesia was first discovered in 1846, and it was used worldwide within a year. And it was ubiquitous after 7 years, like everybody used it. Antiseptics, it was proven to reduce death. It was, it was proven there. It was discovered in 1865, but it was highly divisive. And it was half-hearted adopted in the mid-1880s. And of course, it's now like the foundation of modern medicine, right? You cannot imagine a surgery without a sterile antiseptic environment. So if we compare both inventions, why are they adapted so differently? What is the difference here? And it's quite easy. It's ease of use, right? Anesthesia helped the surgeon work better, right? No screaming patient, no people having to help them. It really helped the surgeon work better. Whereas antiseptics here, it was not very comfortable, right? You had this smoke here, you had this machine, you couldn't see well. So it was in a way back then. And this then is what makes the people don't want to change, right? So if something's uncomfortable, you're more resistant to change. And even if it's proven that there's more resistance here. And you can see this with a lot of other things in the world, right? If something's uncomfortable, you're less willing to change. And if we compare this with what we're doing, I would say anesthesia is DevOps, right? DevOps helps engineers work better. It makes your life easier. We automate things. We give you the cloud, and it's easier for you to spin up environments without going to IT. DevOps makes it easy, and that's why it's adopted quite fast. Whereas security is more on the other side. Security is like, it's in the way. It does not feel good. You have security reviews from external companies. They're outside the process. They come later. Then you already released. Then you have security bugs. You have to fix it in another system. And you have different tools. It does not feel helpful. And this is what I'm meaning if I talk to developer securities. We have to move security and make it so easy, so approachable for developers that it's natural to use it. That you don't even think about it, right? It's in your process. It helps you to deliver secure software because security is important. And of course, engineers know that. They just do not have the right tools to do it. And this is what we're going to talk about today. My name is Michael Kaufmann. I work for a company, Spirit. I'm the managing director in Germany, but we have also offices in the Netherlands, in Belgium, and the US. And we help our customers adopt DevOps practices. I wrote a book called Accelerate DevOps with GitHub. And this is also like a transformational book, how you have to deal with management with DevOps transformation, what KPIs you should measure, and then how you should proactively embed security, quality, and all these things into your pipeline. I work mostly in Germany and with customers all over Europe. But this is a picture of me swimming in the Mediterranean Sea in winter. So I spend most of my time in Spain, close to the water, and I enjoy this. So if we talk about security, I just want to highlight one incident for you to understand how attacks could occur today in an application security environment. And the incident I want to talk about is the event stream incident. Oops, sorry. And event stream incident is a really interesting one because it really shows how supply chain attacks today might function, right? And the target of the event stream incident was not event stream, it was CoPay. And CoPay is an open source Bitcoin wallet. It does not exist anymore, it was renamed after the incident. Event stream is also not an active package anymore. So how did the incident happen? So it started with a social engineering attack on event stream. Event stream was a very popular package, NPM package, and like every popular package, right, you start and being very proud as the maintainer, and then you figure out, oh, this is a lot of work, and a lot of issues coming in, pull requests, just triaging is a lot of work. So one user here, Right9Control, started to helping in the community. And he helped for a few months and gained trust of the maintainer until he got write access to the repository. So what did Right9Control do? He added a new dependency to the package. And the dependency was to flatmap stream in event stream version 3.3.6. And flatmap stream was a new package, only one version in GitHub and one version in NPM. And the community got suspicious. They said, do we really need this? Why do we have this dependency? So what Right9Control did was remove the dependency and update event stream to version 4. Right? So if you would always update all your dependencies and you would directly go to 4, nothing would have happened. You would have not been infected by the malicious code that was then introduced into flatmap stream 0.1.1. But of course, many applications do not update right away. They stay on the older major version, like CoPay, and that's how it got affected by the malicious code. So the malicious code would directly target CoPay, would check at runtime if the application is CoPay, and if the wallet would contain more than 100 bitcoins, it would just harvest the bitcoins, upload the private keys to a control server, and that's it. Right? And you can imagine 100 bitcoins to that time, that was a shitload of money. Yeah. And this is what you have to understand, right? An attack is not only attacking your application, doing a brute force or something, right? You can attack the developer by social engineering. You can attack the development environment, finding secrets there, having unsecured servers running, and so on. You can attack the source code if you have write access to the source code and manipulate, for example, the dependencies. The build environment, the output of the build, the package or where you store it, the deployment while the package is in transit, and the consumer, all are attack vectors that can be attacked. And not only for your code. The problem is that every application we're building today has one dependency, another dependency, and these dependencies have dependencies, and every dependency you add has more dependencies. What you're seeing here is a visualization of all the dependencies of Gatsby. So the moment you're using Gatsby, these thousands of packages are also attack vectors for you. Right? They are also relevant and they can be attacked. And if one of them is not up to date and has a vulnerability, you might be the target. So yeah, we have to consider all these attack vectors, not only for your application, but for your dependencies, for the dependencies of the dependencies of the dependencies. And the problem is that fixing a security bug is very cheap if you do it in production. Right? If you have a vulnerability dependency and you just have to update one version number, it's one change in one file, you have a pull request, and that's it. The moment you fix a security vulnerability during build, deploy, test, or then in production, it gets more expensive every time. And then if you have a breach in production, it might even cause your company to go out of business, right? Then you have a real problem. And that's what we call shift left. Shift left security and bring security to developers, enable developers to move fast and secure and ship frequently, but in a secure way. Okay. I have now a few pillars I want to talk to you about. So first is developer security. So how do we ensure that our developers are aware and can work in a secure environment? Code security, secret scanning, and then the supply chain aspect of security. Right? We start with developer security. A developer is just a really normal employee that normally works as a local admin, can push and execute code on various systems in minutes, and often runs unsecured web servers in our perimeter, right? I said this on another conference, and I said, oh, I really like this, and it's yeah. But it's often the case, right? So how many developers here work with local admin rights on local machines? Yeah, basically everyone, right? And it's still the de facto standard. Developers need local admin rights. They run their web servers locally, especially your Windows development, and then you work with your machines. You often need this, and well, it's also the way of thinking. But this is, of course, the El Dorado for an attacker, right? If he attacks your machine, then all the tools installed, and if you fall for a social engineering attack or a phishing, and you click on something, then it's far more dangerous than someone else in the company, right? It's admin or developer. It's more or less the same. You can do a lot of bad things. Yeah. So phishing is still one of the most common successful attack vectors. And a lot of people are not aware, or a lot of engineers I talk to think that I know what phishing mails look like, right? So we're very good. We're engineers. We know how this works. And yet, if you work for a company that does phishing simulations, you will find that a lot of the engineers still fall for it at one time, and myself included. I clicked on one once, right? Because it was on a mobile device. I did not check, and I know how phishing mails look like. But what people often forget is the priming effect, right? You get a mail in a moment. You have a sense of urgency, and just the context is fitting, right? So you talk to someone on the phone, and he says, okay, I share the file with you, and you hang up, and you get a phishing mail that says someone shared the file in the system with you. Then you're just expecting it. This means you're not critically watching the email. You're just thinking it's urgency, you want the file, and you click on it. Or it's end of the month, and you get a phishing mail regarding your salary. Oh, we couldn't do your salary. Please click here to ensure that we can deliver this. Then you have the urgency. You maybe just check your bank account, and so the money is not yet there. And you say, oh, what happened here? And you click on it, and then later you say, that was dumb, but it happens. And that's why we really have to create awareness from engineers also that this happens, and doing the simulations regularly. But there are also other attack vectors for developers. For example, typosquatting, or namespace shadowing, which is a type of typosquatting. What is typosquatting, right? There are tons of malicious npm packages uploaded regularly. And for example, if you type npm install -env or npm install -env, what happens? So -env is a typo because the real package is called -env. This is the package that you want to have to work with your environment variables. If you type in -env and hit enter, it will steal all your environment variables and upload them to a control server. So it detects directly you as a developer on your machine. And if you have environment variables containing secrets, which a lot of people do, then your secrets are in the cloud. And you might not even be aware of it. Or namespace shadowing, right? So there's a package npm install @azure core-tracing. And if you just type npm install core-tracing, it will also again upload your data to the server. And these attacks are very dangerous because they can not only attack you at the build time, they can also just mimic the other package, and you don't even know it, maybe, right? So maybe here core tracing will just forward the calls to the component to the real package, and it will just include the real package as a dependency, and then just forward everything. So it might be in your code, and you don't even know, and then it can attack to runtime your end users, for example, like it happened in the copay thing, right? So these attacks are very, very dangerous, and you really have to monitor your dependencies and what's in them. So what can you do if you have the credentials of a developer, right? You can, for example, go spear phishing and write direct phishing messages to admins or someone. And because they're coming from an engineer, people are more likely to click on it, right? So this is a real email from within your company. This is, dangerous. Developers often can log on to a lot of machines, and test machines, engineering systems, and then you can use Mimikatz, for example, to get credentials from other people's on the machine if you don't have the latest patch versions of Windows 10, or other credentials the user used and cookies. You can inject code you can normally execute code in pipelines if you can modify, right, infrastructure as code, pipelines as code, or yeah, have test environments. And some developers have access to prod, right? Then it's already game over, and you can directly access the prod database and just download it, and you have a big data breach. So what can we do? So of course, security awareness is very important. Like phishing simulations, you should do it. There are awareness trainings, awareness games that you can include in your sprints, right? Every sprint end, you can do a 15-minute game, and then this already creates a lot of awareness. What I really love are red team, blue team simulations, or capture the flag events. And I think this is something, if you give a developer an Excel spreadsheet and say, hey, do here evaluation of possible attack vectors, they will hate it. If you give them a few days and say, okay, go and attack this, and we give you a coach that helps you do this, and they can get live coding, they will love it, right? So this is a good experience, but it creates a lot of awareness, not only for the teams doing it, but also for the other people, because there will be a report. And of course, it's anonymized, but if you are in the report and you know you've been the people that left a file with credentials in it somewhere, then you don't want to be part in this, right? So it creates a lot of awareness from all teams. And it also helps engineers think like attackers, right? So it's just a different way of thinking. And I don't have too much details here about red team, blue team simulations. There are a lot of companies offering this, right? Purple teams, red team, blue team, capture the flag, a lot of events. But I think the important part is here, do not have someone else do pen testing for you and say, here, please attack this. Have someone teach you how to do it, right? So have someone to coach you and helps you find the right teams, the red team, the blue team. If you have a SOC center, then you probably just have to put engineers here for the blue team, find the red team, define the scope, because you need a good scope. Okay, what can we attack? Of course, you don't want the production system to go down. You don't want real user data to be breached, right? So there have to be some rules and some good scenarios. So look for someone that helps you, really enables you to attack yourself, and not just do it in a closed scenario and then comes with a report, right? So, and that really creates awareness. The other thing for developer security, and this is one of the things that I really think is a good example for anesthesia, are virtual development environments. They're not just much more secure and help you also, do not work as a local admin, but they're also much more productive, right? So you can reduce the onboarding time for new developers from some companies days, at least hours, to minutes. And even if a developer and you're 2 months away on, I don't know, maternity leave, and you come back, you still have a new virtual environment with all the new tools, with all the new versions, and you can start coding in minutes instead of hours, days. So this is really, it is more secure and it is more productive. And this is my first demo. I wanted to show you GitHub Codespaces, and now GitHub Codespaces is not part of advanced security. It's also more a production feature, but anybody already using Codespaces? No? Then great. So here you can see a GitHub repository, and if you go to code, oh, that's the wrong one. Damn it. So here if we go to code, you can see in the repository included Codespaces. And let me just open this. You could create here a new Codespace. Let's pick new with options. And you can see here the different options, right? We can pick a branch, so you can have individual development environments per branch. For example, get a main branch. You pick a dev container file, and this is built on the normal Visual Studio Code dev container architecture, so nothing special here. And you can have multiple in a repository. If you have a bigger repository, you can have different environments for front-end developers, back-end, database, and so on. You pick the region and then the machine type. And here if I open the machine type, one thing I want to highlight, you can see here you have different machine sizes. You can disable in an organization what you want to be available for the engineers. And you can see here this machine has a pre-built ready. So you can configure pre-builds, and you can configure the pre-builds that they run, for example, on every check-in. And if you have a big monorepo that is very large, so every check-in now to main would trigger a new build in the background. So you can directly start working on the new latest branch of main here without having to do a pull. And in the big monorepo, this helps you speed up. You can also schedule it and build it every time, every night at, I don't know, 2 o'clock. You can also only build this on configuration changes. So a lot of options here. Okay, I already have one running here. And yeah, you could open this here in the browser, which just runs a Visual Studio Code in your browser. In Visual Studio Code, locally, it will then tunnel to the machine in Azure, JetBrains Gateway, or Jupyter Lab. So I just opened it in the browser now. And this starts a virtual environment, container-based in Azure, and Visual Studio Code in the browser that uses the client-server architecture to connect the machine. And it has a timeout of 30 minutes, and apparently I passed it. I started the machine earlier, but too late. I talked too much. So this is a cold start now, right? After 30 minutes, it will just shut down. You can configure this also, but the default is 30 minutes. And then it restarted. But you can see this is only a few seconds, right? And if you have pre-builds available, this is also the time it takes to set this up. And for example, now, if I do a .NET ---- version, this is the .NET environment on the virtual machine, not on my environment, right? And you can completely customize this with containers, multi-stage containers. Everything that you can do here with Visual Studio Code and containers and dev containers is available here. And one thing I want to show you, let's just do a .NET run. Now you can see it detects that I'm running a port here, 5111. And I can say open in browser. And this is my application, my .NET application running in this virtual development environment. And you can see that this is a secure, this here. This is HTTPS. Even if the protocol is only HTTP on the development environment, this is tunneled from the virtual machine to my browser. So this is a secure connection. But if I go into the dev container here, you can see that I have ports, one port available. This is HTTP, and the port visibility is set to private. So only in my browser I can access this application here. But I could change the visibility here, right? I could change the visibility to in my organization or to public and send the URL to a user. So if you have problems reconstructing a bug, someone reported a bug, and you cannot reproduce it, you just send them the link. And you can debug in the background, you can attach a debugger to it, and they can click through the application. And this makes it a lot easier to find things, right? This helps also in communication. Of course, this is Visual Studio Code. You also have live share. You can do live coding with other people. And for me, this is like this is a production issue, right? This helps you to be more productive, and yet it's more secure. Right? So this is everything we want with developer security. So developer security, code security. Let's talk about the code itself. So normally it's more than 4 years that vulnerabilities are undetected in code until they are discovered, right? So Log4j was vulnerable for 7 years. Nobody knew about it. So if you discover a vulnerability like this, it's important to react fast. And it's important to also do variant analyses to find if the same vulnerability that was found here is also true for your code, right? So Log4j was a serialization issue, so you could just inject something in the deserialization process, and this could also be true in your code if you're using Java. So yeah, let me introduce you to CodeQL. CodeQL was acquired by GitHub. It was called SAML before, and it's a very advanced code analysis. based on a research of 30-person team over 13 years. So it's a lot of research that went into it, and it finds a lot of vulnerabilities, right? These are the numbers from, I think, 2018 and 19. The CVEs, the common, the vulnerabilities that were detected by the different tools. It's just, there are other good tools. The way that GitHub is doing it is they create a database out of your application. So actually multiple graph databases. So they do not only have the syntax tree, they also have the data flow tree. So they know how data is flowing through your application. I will show you later. And this way, you can easily write a query to detect a source or a sink if there is a match in your code. Right? For example, log4j, there was the source, a user input, a file to be serialized or deserialized, and there was the sink, the vulnerable executable that could be forged by having the input. So you write a query, and I think it was only a few hours after the vulnerability was detected, there was a query available on GitHub that would detect the same thing or variants of this vulnerability in your code. Yeah, so combining CodeQL with the world's largest developer community, this is what's it about, right? So CodeQL is a very easy language to write these queries, to analyze your applications and to see if vulnerabilities are met with user input. And all the queries are open source, right? And GitHub itself has a lot of security researchers, but a lot of other or independent security researchers also publish their queries on GitHub, right? And GitHub has all the data, so you have all, or the most big dependencies on GitHub, they are on GitHub. So GitHub sits on the data, so it's very fast, and also the CodeQL queries are there. But GitHub Advanced Security is not only about CodeQL. GitHub Advanced Security is out including all the other tools into your development process, right? So, for example, infrastructure scanning. So here are some examples, for example, Anchor or White Source, they all have integrations into Advanced Security. So you just add the action, and then it will show the results directly in GitHub if you modify the code file, for example, in a pull request. Another example, for example, is Checkoff. And I include this in my demo later. So Checkoff does not have native support for GitHub Advanced Security, but it does support Serif as an output. And Serif is an open standard, so you can just use the upload Serif action in actions and then upload the results. So every tool that supports Serif can be included natively in your development process here, right? And shift left. For example, here Checkoff, it's an open source tool. It has more than 1,000 rules for Azure, for AWS, best practices, and you can just include it in the pipeline the same way you do with CodeQL, and it will fail a pull request, and you can see in your, for example, Terraform file, you can directly see here that you are missing some best practices. So let me show you. So let's close this. So this is my GitHub repo from the GitHub Advanced Security Bootcamp. And if you go to Code Security and Analysis, and let's go down to GitHub Advanced Security, and here you can see code scanning. And of course there's normal CodeQL analysis, but then you have also other tools. And if you click on Explore Workflows, it just brings you to the new GitHub Actions workflow page and filters by the category security, right? Because these are all security tools that support the Serif output, and you can integrate them into your advanced security here. For example, of course, the first one, CodeQL. This is what we're going to look up now. But then you have a lot of other tools, right? Checkmarks, Stackhawk, SamGrab, Sonar Cloud. All these tools that you now have in different portals, in different reports, you can integrate it here as long as they talk Serif. So this is how a CodeQL workflow looks like. This is just a template. So per default, it gets triggered to pushes to the main branch, and it gets triggered to pull requests to the main branch. But you also have a cron job here that runs here, in this case, once a week at a random time and day, because there might be new queries in the background, right? There might be, so even if you don't touch the code, there might be new queries. For example, log4j, they found it, you have a variant analyst, and you still want to run the analysis even if you did not change the code. You have a question?
Yes, do you know if you can enable this across all and set these actions up across all repos in an organization? For example, an organization has hundreds of repos.
Yes. There's a new feature, it's very new, came out a few weeks ago. It's called required workflows. And you can basically define here the required workflows. But it's not so easy, because if we scroll a little bit down, you see that there is a build step in here. So let's first go through the other things. So we have here the matrix strategy, meaning you have here one job per language. So these are all the languages GitHub detected in your repository, right? We have Go, Java, JavaScript, Python. So for every language, it will run on its own. Then we have the initialize CodeQL with the language. And this is where you can configure it. Here you can tweak, you can exclude some queries, you can include queries. There are different query suites, right? Default is security. Then you have security extended and security and quality, which runs longer and finds more things. And you can completely customize this. And then you have one build step or one step here in the job that is called auto build. And this is just an action that just tries to build everything it finds. If auto build fails, you can include a version number here and use a setup task, for example, set up Java and then give it a version. Or you can include your own build steps. And this might be the problem from the required workflow that you have to fix, right? If auto build is not working, you might have or give people the possibility to tweak it. And it's also something, just enabling it for all teams, I don't think it's best practice, because if they have too many findings, they will just ignore it. If they don't have any findings, they think it's not relevant. So finding the right amount of queries that you have, so you could have one basic analysis with only the security things, but you still should try to enable the teams to configure it on their own, to get more out of it and have also quality rules, but not too many, right? So you don't want 1,000 issues because nobody will address it. If you have just 10, 20, then you will fix it the next sprints. So I think that's the finding the right amount of vulnerabilities is very important. Yeah, so that's the workflow. I already have one. The results you find here in the security tab. And then under code scanning. And for example, we have here the serialization of user control data. And you can see here, this is what we're talking about. Read object. This is vulnerable if we inject a malicious file. And we can here click show path. And then you can see how data is traveling through your application, right? So here we have the request param, we pass it in as a file, read bytes, and this is where you can see how data travels through your application, and at some point we find it here and say, hey, we have the input stream. If this file is manipulated, it might result here in an issue. So this is how the queries look like. They're all open source, so you can see the view source here. You get a lot of information here about recommendation, why is this applicable, what can we do to omit this, and this is how it's surfaced to your developers, right, in GitHub. But of course, it's this where you find all the security issues and can dismiss them, but you can also integrate it in pull requests. So, for example, here. You can see, right, this is the malicious code, line 28, and directly in the pull request, you get this issue here surfaced before you make it to the main branch, and you can here work from here, dismiss it, show it, fix it, and whatever it is. And let's look at the other pull request. So here you can see checkoff. I also included checkoff here. uploaded a Sarif file, so it's also integrated in the pull request. And if you add here a Terraform file that does not align to best practices, you will get a warning and the pull request will fail, right? So in this way, you can include all the tools that talk Sarif into advanced security and make it part of the pull request experience. So not after the fact that you merged it, but with your automatic checks and the build process, you can run all the checks at once. So that's what we talk about shifting left security. Okay, I think that's code analysis. Another important point is secret scanning. So I think in 90% of all incidents, at some point, there is a leakage of credentials at some point, right? So maybe not the first step, but then in a subsequent step. So checking your code base, your file shares, and everything for secret is extremely important. And we're seeing more and more credentials leaks over time. So this is the public data from GitHub. And my colleague Rob, he did an analysis on all marketplace actions, GitHub actions in the marketplace. So he cloned it in an organization and ran secret scanning and also code scanning over it, and he shared the results in his blog. And it's incredible how many secrets are in the repositories that publish actions to the marketplace, right? It's really frightening. So, and it's free, it's open source, right? So in open source repositories, secret scanning is free, so they should get an alert, they just do nothing against it. But in your company, of course, it's not free, you need advanced security, but checking regularly for secrets is extremely important. And of course, there are other tools that you can leverage, right? GitLeaks, Spectral Ops, Git Secrets, or just Dumpster to analyze your file shares. But of course, shifting left, meaning being close to the developer. And GitHub secret scanning has over 80 partners right now, right? All the big cloud providers are GitHub secret scanning partners. And you can also see a shift in the industry. Right? A few years ago, all the secrets were just a bunch of letters. And now all the secrets have a prefix. So it's much easier for secret scanning to detect what kind of secret it is. And in the past, it was like security by obscurity, right? So you don't know what the secret it is. You have to try it out. But of course, hackers, they try it out. And they automate this, so it's not really secret or not really helpful for security, right? So it's much better to add a prefix so that so secret scanning here knows right away that this is a secret and can inform you and allows you to revoke it or take measures, right? If it's just a string, you don't want secret scanning to try out if it's a real secret or not. How does secret scanning work? So for public repos, you have the partners in the background, for example here AWS. So if you find an AWS connection string, it will inform AWS. And then it's up to them to revoke it or what to do it, right? You get informed on GitHub side, and it's up to the partner to inform you. In your private repos, this is not the case, obviously, right? So GitHub does not want to send your data, if it's not sure if it's a secret, out to some third party. So you will get the alert on GitHub, and it's up to you to take measures if you want to revoke it, if you want to rotate it, or what you want to do. Let me also do the demo. So let's go again to settings, code security analysis, and here we have secret scanning. And there are not a lot of options. You can disable it, obviously not a good choice, and just enable it, and then it will scan your repository. Also the history, right? Not only the current state, also in your history, it will search for secrets and surface them the same way it does with code analysis results. Two features are important here, and the one is push protection. So if you enable push protection, it will prevent secrets from being pushed. So even from the command line, from your IDE, it doesn't matter. From any system, if you do the normal git push, it will analyze it, it will scan for secrets and alert you if there is a secret in it. You still can override it, so you will get a URL, So in the web, it's just a link. You click on it. On the console, you will get a URL. You open it in your browser. You authenticate. And then you can choose to override and say, no, I need this. This is a false positive, or we need this from testing. You still can override it and push it. But it really helps you, right? Not just alert you after the fact that their secret is already there, but prevent it from even reaching it. So that's one important feature. I don't have a demo prepared for it, and just believe me, it works. The second one are custom patterns. So you can create your own patterns. And this is a regular expression. You have also before regular expressions and after regular expressions for more complex scenarios. And then you add some test strings here. And then you can do a try run. And the try run will then surface how many of the test strings or of the secrets were found matching that pattern in your code base, and then you can enable it, right? So it's not like, okay, you have to enable it and you have a problem. You can first try out, see how many you find, and then enable the pattern. And so this is a public repository on GitHub with a lot of examples that you can use for advanced security, right? For example, configuration secrets, JVTs, personal identifier, credit cards, RSR keys, and so on. And everyone here is a file. You can click on it, and then in the README, you have your pattern format, right? So this is the normal pattern, this is the start pattern, and this is the end pattern. And you find here already predefined patterns for different databases, credit card information, you name it. So this is a good source. So all our advanced security customers, they heavily use these custom patterns, right? So, but you have to tailor them sometimes, but here this is a good starting point. So if you enable this under security, secret scanning, you can find all the alerts here. And again, you can see the secret, where was it found, 2 years ago, introduced in the database, and you could close it and say, okay, revoked, used in tests, false positive, won't fix. So this, again, very easy way here to interact with the found secrets. So that's secret scanning. So last of our pillars is the supply chain, the dependency graph. And we call this software composition analysis, right? Analyzing what your dependencies are and what their dependencies are, the transient dependencies. And of course, again, there are other tools, Anchor, dependency track. And in GitHub, we call this the dependency graph. And the dependency graph, if you go to GitHub, it's enabled per default for public repositories. And you can see all the dependencies for all manifest files in your repository, and you can see all the dependent or dependencies of them. And in the repository, you also see dependents. So if you are a package and you are consumed by someone else, you can also see it. So this way you can, in GitHub, traverse the tree and see the code and see the vulnerabilities. Right? And if there's a known vulnerability, you can see it here in the dependency graph. Check the next slide. So what can you do with the dependency data? So once you know what dependencies you have. You can use Dependabot to help you or to alert you first. Dependabot alert you if there is a known vulnerability in the dependency. And dependencies here is not only npm and NuGet, right? This is, for example, also Git submodules, Python, pip, GitHub Actions. So if you are using GitHub Action workflows, each action has a version number, right? And each action is a dependency, and that might have other dependencies depending on the type of action you have. So you also want to get alerted if a GitHub action has a vulnerability, right? Submodules, so a lot of different manifest types are supported here in GitHub. So then Dependabot can alert you. Dependabot can send you an email right away and an alert right away. You can get a daily digest or a weekly digest, but it will alert you if there's a vulnerability, if one of your dependencies or dependencies of dependencies. But Dependabot can do a lot more. Dependabot can for example, provide you with security updates. So if you have a vulnerable dependency and there is a fixed version, so downgrade or upgrade, it will create a pull request for you. So you should just have to approve the pull request and then you're up to date. And this reduces the amount of time needed to fix vulnerabilities tremendously, because you don't have to do anything, right? So the pull request is here. If you have good automation in place, automatic tests, your build runs, everything is successful, there's no reason not to accept it, right? So you just approve and then you're up to date. And since Dependabot can do this, you can do even more, and you can do version updates. So even for non-vulnerable versions, you can use Dependabot to create pull requests for you to keep up to date. And you can then use, I will show you this in the demo right now, and then you can use, for example, GitHub Actions. There's a Dependabot metadata action, and you can use this to automatically approve some updates. So in this example here, I think this is a little bit small. So you can see this workflow only runs if the actor is Dependabot. You get the metadata from Dependabot, and then if it's a patch version update, it will automatically approve this pull request, right? This way you can, for example, have different workflows for different, you can also here filter by the name of the dependency, and have for some dependencies always upgrade all versions, always update minor versions, always update patch versions. So this really helps you automating this process of updating your dependencies and keeping them up to date. So let me go over. So this is Insights, and here we have our dependency graph. And the dependency graph is populated automatically, right? You do not have to configure it. And you can see here all the dependency, all the manifests that it detects in your repository, right? Front end, package log JSON, package JSON, requirements text, everything it finds, and it surfaces all the vulnerabilities here. And you could then drill in here and see the dependency and the dependencies of the dependencies and so forth, right? So this is the dependency graph. And I don't have workflows in here. I don't have workflows in here. Not yet. The results are displayed here under security, Dependabot, and for example here, prototype pollution in Webpack. No, this is a new one. Yeah, that's this. So you can see here the severity, how the severity is calculated. You see the common weakness enumerators here. You can get more information. So this is from the GitHub advisory database, right? And the GitHub advisory database contains the NIST database, so the global one, also the public one, plus some additional advisors that are only relevant to source, open source and are not yet in NIST. So you normally have the NIST ID and sometimes separate. So this is the NIST ID, the CVE ID, and this is the GitHub Advanced Security ID. And you can see here affected version between 2.0 and 2.03, patched version 2.03. So Dependabot knows to update to version 2.03. Yeah. And now let's go to pull request. And you can see here, which one and what? This one. I wanted to show you another one. Yeah. So this is the pull request created by Dependabot. And you can see here the compatibility score. So based upon data from open source, analyzing the other CI builds that run for these dependencies, it calculates a score how possible it is that these changes are compatible with your code. 90%, not 100, but still not bad. Right. You have the release notes, what is in there. You have the change log with the individual commits, Here the individual commits, where you can jump to, because if you look at the changes, it's just a version number, right? So this is not really helpful. You just see new version numbers. So Dependabot gives you a ton of additional information that helps you decide if you can update this without a problem. Of course, if it's a pull request, it should run your automatic build and your automatic tests, and if everything works well, then you have an indication that everything is good. And since Dependabot is a bot, you can communicate with this bot by commenting on this pull request with one of these commands, right? You can, for example, say, tell Dependabot to rebase these changes. You can tell them to merge it. You can cancel it. You can reopen if it was closed. You can say, please ignore this minor version. Please ignore this major version. Please use these labels. And then Dependabot learns that it should apply these labels to similar updates, right? So this is really how you interact with Dependabot here and teach them what to do and how to deal with your changes. But of course, this is for vulnerabilities in your code base, right? Dependabot runs in the background and alerts you. And you can also have a dependency review in your pipeline and check dependencies that you add to your code base if they have a known vulnerability in one of their dependencies. And I have another example here. For example, a pull request, update requirements. So I added a dependency to Django, and the pull request is blocked for merging because dependency review fails. And if we go to file change, you can also watch manifest files in this new view. And you can see here all the dependencies that come with the dependency are added to the text file, right? So there's just one line here. I just added Django to the file. Oops, not what I. So, and you can see here all the dependencies, and you can see there are critical severities. So that's why it blocks the pull request, and you cannot merge it back. Yeah, so I think that's it for Dependabot. And yes, of course.
Yeah, does it plus points to use the bot and all security features in GitHub?
Not for open source. So all these features are free for open source. Like GitHub Actions is also free for open source. If you have public repos, it's free. If you have private repos, you have to pay. Yeah. Then you need the normal GitHub Enterprise license, and you need a GitHub Advanced Security license on top of it. Any more questions? No. I mean, this was, of course, an overview. Right, and I think it was more important for me to set it in perspective. Okay, how can we shift left? How can we use these things and put it in the pipeline to make security a little bit more anesthesia and less antiseptics, right? Not interfere with you, and have all the security tools surface in one point and bring it to the pull request, bring it there where developers want to work with it, right? So I want my pull request to fail right away. I don't want to get notified 3 weeks later and then fix something. I want to shift left. And we have GitHub Advanced Security bootcamps. So this is like a one-day workshop where you have a lot of hands-ons where you can really dive into it. But for me, it was important that you can see, and GitHub Advanced Security is also just an example, right? So there are other tools available that you can put together. But I think it's important to think of developer security and not application security as something that comes afterwards, as something that blocks us, something that keeps us or slows us down, right? Security is important. Everyone knows it. We have to embrace it, and we have to enable our developers to do the right thing with the right tooling. With that, thank you.